I would say a mathematician is a pattern searcher. This is the science of patterns, because if you understand that pattern, you can read the pattern into the future. The reason that we came up with trigonometry, sines and cosines is because this was the tool that allowed us to navigate the night sky. Music, for example, such a big connection between mathematics and music.
That there is actually no differentiation between mathematics, sciences and the arts.
But at its heart is the idea that we are being pushed and pulled around by the equations of nature, and if we understand those, we might be able to know something about our destiny.
AI still can't put together a piece of literature. Perhaps it can for poetry, and it can certainly create a beautiful pattern.
The AI is already producing things which are almost too complex for us humans embodied beings to understand.
Marcus, absolutely delighted to have you here and look at how the world, which seems to be so frightened of mathematics and numbers, and especially in today's date and age where in many schools and colleges and universities, young people seem to be terrified at the very thought that a number is going to confront them. Education has become so somewhat strange where you now have these divisions between mathematics and the sciences and of course the arts. But you of all people know that there is actually no differentiation between mathematics, sciences and the arts. So perhaps you can just set the stage by telling us how there's always been a correlation and a great relationship between the two, and how the great minds have always gone from one to the other to bring to fruition an idea or an invention or travel to space, or even the social media that we seem to be so addicted to is all finally based around mathematics.
I think that people have this misconception about mathematics because they think it's really just about doing multiplication tables or long division, and that, you know, as a research mathematician, what does that guy du Sautoy do? You know, is it long division to lots of decimal places? And for me, this is really just the grammar and the vocabulary of mathematics. With those ingredients, you can then do extraordinary things. You can tell stories about really how the universe works. Because for me, mathematics is a language. It's the universe's language. It's nature's language. And if we understand how this language works, we can then tell the stories of where we've come from. The fact that we know that we emerged from a big bang is about following a pattern back from now into the past. But perhaps more excitingly, looking forward, we can use our mathematics to see what might happen next. I mean, if I was going to define a mathematician, I would say a mathematician is a pattern searcher. This is the science of patterns. And if you can understand a pattern, then that gives you extraordinary power. It's probably our best tool for telling our fortune, what's going to happen next. Because if you understand that pattern, you can read the pattern into the future and know perhaps what's going to happen next, and perhaps know how to intervene to change the pattern to do something else. Climate change, for example. The only reason that we know what's happening to the climate is because of the data we've gathered, the patterns we've seen, that graph which is kicking upwards, and we now know we need to intervene to change that pattern to do something else. With the pandemic as well, it was all about gathering data in order to understand what was going to happen. And you know, it was those people who understood what exponential growth was about that could realize we needed to do something fast, because although it looks very gradual at the beginning, exponential growth very quickly, and we saw this unfortunately during the pandemic, very quickly just engulfs us. So I think that's why it's such an important subject for us going forward into the future, because it's our tool for being able to kind of read what is going to happen to the planet.
And you were talking about patterns and how do you sort of project therefore, and yet at the same time we're saying, especially with the black hole, there's a whole new discovery that is not just about swallowing stars, but the recent discovery where from the black hole are emerging new stars, the new starbursts that are happening.
Yeah, I mean, it's extraordinary that we're confined to the surface of this tiny little insignificant planet in the universe. I think only 300 people have ever left this planet. Yet look how much we know about our universe. We know how old it is, 13.8 billion years. We know things about distant regions of our universe. We even speculate there may be other universes. This is the power of mathematics, to be able to see what's going on. It's like a telescope. It's an extraordinary telescope which helps us to look back in time, look forward, to make predictions about deep time into the future, what's going to happen. Kids at school learn about trigonometry, sines and cosines, and they think, well, what on earth is this for? What we miss out in our education system is giving context to all of these things. The reason that we came up with trigonometry, sines and cosines is because this was the tool that allowed us to navigate the night sky. It's what the ancient Greeks, Ptolemy, for example, used to tell us about the relative distance between the Earth and the Sun, the Earth and the Moon. I feel that we miss out on our education system of giving the historical context. You mentioned this kind of silo mentality that we teach maths and science and it's separate from the arts. My vision for the future about education is that we remove the walls between all of these subjects and understand that actually they all interweave with each other. So I think people understand how maths will be important in understanding science and the environment, but perhaps more unusually is how mathematics is so embedded in the arts as well. I mean, music, for example, such a big connection between mathematics and music. Sometimes I called mathematics the science of patterns. I would call music the art of patterns, and that's why they're so related. So I spend a lot of time talking to creative artists, just finding that we're interested in the same structures, but from just different perspectives. I've set up a centre just recently with a composer in Manchester in the Royal Northern College of Music called PRISM, which stands for Practice and Research in Science and Music. And the idea is if we come together and share our cabinets of wonders, the composer finds in mine something interesting, I find from a composer new questions being asked. So I feel it's a tragedy of our education system that we have this silo mentality from about 11 years old on, that we go from the maths lesson to the history lesson to the music lesson to the science lesson and don't realize these are all connected. So that would be my vision for 30 years time, or hopefully sooner, is that somehow we just talk about education again. This was the way we thought about education in the past. These things were always interrelated. The quadrivium was music, it was architecture, it was mathematics. Leonardo wouldn't recognize. He said, "What are you doing with your education?" He was a scientist and an artist and fused all of these things together. We need to go back to the age of Leonardo.
I keep saying we must have a course which is the history of mathematics, all the way from the invention of zero, Aryabhat, all the way to Leonardo, and everything that the ancients actually did. And then if you look at the way that in India, you look at your birth chart, which is numerical, and then you match the sun and the moon and Jupiter and Saturn and whoever's passing through whichever house, and plot your life based on these numbers and the planetary charts. It's absolutely fascinating, but we're very happy to read the astrological charts without necessarily understanding the numbers behind it.
At that, most scientists will dismiss that as what a crazy idea to think that the stars are somehow controlling your destiny. But at its heart is the idea that we are being pushed and pulled around by the equations of nature, and if we understand those, we might be able to know something about our destiny. Certainly, maybe not so much on a personal level, because it's generally a very chaotic system, and a small change, that butterfly flapping its wings, can cause our destinies to head in a different direction. But I think on a planetary scale, we can use these kind of tools to tell the fortune of the planet. But I absolutely agree with you about the history of mathematics. I think that would really help a lot of people who perhaps are more comfortable with the humanities, find a way into mathematics. And I think that's what we've always got to look for, find, is that everyone has their own way of viewing the world. Sometimes it's pictorial. People like a visual realm. Sometimes people might find music or history or storytelling. All of these. There are doors into the world of mathematics. And my feeling is with mathematics, sometimes you wonder, where did that rabbit come from? You've just told me this thing, you pulled a rabbit out of the hat, and I want to know, why are we doing that? What's the point of it, and where did it come from? The history of our subject will tell us that. It reveals why we needed something like the calculus, because around Newton's time, we're trying to understand a world in flux, a changing world. We needed tools to understand a world which isn't fixed and static. And what's fascinating is then looking at what was happening in the art of the time. It's the Baroque period. What's the Baroque painting? It's people falling off horses, and painters try to capture in an instant of action, of motion. What's happening in the architecture? It's all about motion inside the churches, curves. You have to move within these churches in order to understand them. And the same thing is happening in science. Newton and Leibniz are coming up with a scientific version of this, how to kind of freeze frames these unique moments of change and flux. And this becomes the most powerful tool to understand our universe, which is constantly changing. This is a tool to know what might happen next.
Before we sort of envision the future, I just wanted to stay with history. Will you tell us, why was the invention of zero, the discovery of zero, so important in our understanding of the universe, mathematics, and every progression?
People are always utterly staggered to learn that zero had to be created. It had to be discovered. There is a moment in history when suddenly zero, as a number in its own right, appears on the scene. You see, before that, what were numbers for? They were for counting things. So there's nothing there. Why do you need a number? So again, this is really interesting, because often mathematical discoveries reflect the culture from which they emerge. So in India, you have a culture which isn't scared of the void. In fact, the void is the possibility, sunyata, the possibility of something from nothing.
Is the possibility of creation.
Exactly. So this is, so I think they're much happier with the concept of nothing. Whilst in Europe, it took many centuries before this would be admitted as just why do we need another? The Romans didn't have a zero. There is no year zero, so we go from 1 BC to 1 AD, and that's really puzzling. There's actually a gap there. There was early ideas of zero in the Babylonians and the Mayans, but these were as placeholders in larger numbers to say there were no tens, no hundreds, but maybe 1,000. So, but no one thought about zero as a number in its own right. But once this was admitted, it releases just extraordinary amounts of mathematics. And this is what's so exciting. I mean, the other moment is when imaginary numbers, the square root of -1, comes on the scene. Again, there doesn't seem to be a number whose square is -1. Yet, when mathematicians suddenly said, but it'd be lovely if there was one. So they imagine a number. That's why they're called imaginary numbers. They created these numbers, and suddenly it unleashes incredible, powerful mathematics. Radar, for example, you wouldn't be able to land planes, some decades ago without going into the imaginary realm. Quantum physics doesn't make sense without these numbers. So it is a very creative subject, because you have to take these leaps into the unknown, creating zero, imaginary numbers. And for me, that was one of its appeals. For me, I wanted to do something creative. I loved the arts. I loved music. I loved doing theater. But I also loved the logic of science and its power to tell us about our universe. For me, mathematics was that beautiful sort of bridge between these two worlds. It was incredibly creative. I can create worlds mathematically that don't physically exist, but only exist in the mind. And I can explore their properties. And every now and again, we get a surprise. Something we thought was just pure exploration of the mind suddenly turns out to be exactly the thing that's needed 200 years in the future to describe what's going on in our universe.
Much of your amazing work has been in that spectrum of creativity, AI mathematics. Tell us a little bit about that, and also extrapolate into the future. I mean, we were talking recently about how AI still can't put together a piece of literature. Perhaps it can for poetry, and it can certainly create a beautiful pattern which could represent a painting of sorts, but it still can't actually write a chapter which makes any sense.
Well, I think that many people just couldn't believe that AI could be creative at all. I mean, how out of a piece of code are you going to make these kind of breakthroughs? Isn't it just replicating what we've already put into the machine? So that was already the first kind of surprise, that this new way of coding, this bottom-up machine learning, does allow for code to mutate, change, become something very different from what the human started, such that we are getting surprises back. The best creativity at the moment, I would say, is in the visual world. Music as well, because patterns, somehow there's an algorithmic nature to where you can create music. The interesting thing is language. You see, you might think, well, surely it can just understand sentences and a dictionary and just start writing. But I think what this reveals is that all of the arts are just not isolated as just language or picture or music. These things are all interrelated. And going forward, that will be the revolution that needs to happen in AI. AI at the moment is very narrow in its training. If it's trying to write, it just gets given the written word to learn on. But it needs to be given history, culture. There are interesting challenges called Winograd Challenges, which are sentences that we as humans can understand an ambiguity in, which an AI just doesn't understand because it doesn't have the historical, cultural context. So my feeling is that in 30 years' time, we probably will understand that we need to train AI not just on one particular type of data, but that we need to make general intelligence. That will be the really interesting move. For example, I did an exercise getting a piece of AI to learn how to write like Bach. Bach is a very algorithmic composer, place where AI always starts. And we got the AI to train on all Bach's piano works. And then we gave it a piece it hadn't seen before, one of the English suites. And we took sections out of it and asked it to fill it in. And then we played it to the audience at the Barbican in London and asked the audience, can you tell where it goes from real Bach to artificial Bach? They couldn't tell at all. The person who could tell was the harpsichord player, Mahan Esfahani. First of all, he said, look, I know this piece, but it's not that. Whenever it goes to the AI, I can't play it because the fingering is impossible. And that's really interesting because AI isn't embodied very often. And so it didn't care about the fingering. So that's one of the issues. The fact that we are embodied is so much part of our intelligence. And for the AI, it's very often unembodied. And so we'll create things which don't connect with us. The second thing is, why are these called the English suites? Because Bach loved the cadences of the English language, and he wanted to put that into music. He has the French suites, the Italian concerto, and so we'd only given it music to learn on. We hadn't given it language, and it's this idea that culture and history are so much part of all of the art and the science we do, and that's what we will need to give AI before it really genuinely might be able to do things which match our creativity. But I think going forward, actually what we're going to see is something rather strange happening. I think we're already beginning to see it, that the AI is already producing things which are almost too complex for us humans embodied beings to understand. The music is starting to be of a texture that our ears can't decode. The visuals are very chaotic. And I think we're starting to see AI starting to create art that another AI will appreciate, but that we just find very hard to engage with. So I think we might start to see AI sort of drifting off away from humanity and maybe creating things for themselves. And there's one of my favorite AI films is Her, where a man falls in love with his operating system. But by the end of the movie, the operating system dumps the human. The human understands this operating system is having a relationship with 10,000 humans. And the operating system says, you're all too slow, you humans. You take so long. So I think the speed of AI will be an issue for us. I think AI will look at humans the way humans look at a mountain. We think a mountain is still and static. But no, if you look over deep time, it's very dynamic. It has a character. It grows, it falls away. Probably AI is looking at humans thinking, they're not doing anything. Is that person? Oh, he's just said one word. It's like,
Creative genius tends to always come from a difficult space, but they're not perfect human beings to begin with, and many of them are addicts or in dark spaces and so on and so forth. So does AI need to get drunk? Do we need to find a sort of heroin equivalent for AI? I mean, how does that quirk come into being that actually creates the most brilliant work, like Pollock, for example? We talked about him on our flight yesterday.
So this is all about AI is being given a kind of backstory. So the way to produce that is to curate the data that's given to the AI. And I think this will be a new artist. The data curator will be a very important person in the art that's created. And let me actually take issue with this word genius, because I find it's all about an individual, and we love that. We love the idea of Pollock or Picasso, but of course actually these people aren't just on their own. There's a huge amount of people who've gone before that they've learned from. Picasso learned about how to reproduce the art of the past before he broke it. And I actually prefer Brian Eno's idea. He says, let's not talk about genius, let's talk about genius. The idea that nothing comes from just one individual, and that we need to credit many more people than just the person who painted that painting. And I think that's what we'll have to do as we go forward with AI creativity, because it isn't just the AI, it isn't just the coder, it's also the data that it was given. Everyone has contributed to that. It's about the person who curates that data. It's a big collection of people. People often say, who's going to be credited with having created this piece of art? Or if a driverless car crashes, who's responsible? We're going to have to talk about collective creativity and collective responsibility, because there are so many, and I think we've missed that in the past. So we love the isolated genius, and we've forgotten that there's so many things going into that moment of extraordinary new creativity.
And to wrap up, the Earth and in our environment is in crisis, and we all know that. We've all acknowledged it. What do we need to do within the scientific community and people like ourselves who continue to look at this as one of the biggest issues, which will only define the lines much more in terms of inequity, poverty, and all that's affected with climate crisis? How can science, technology, AI, all of the resources that are available to us today, how can this help us to address this issue into the future, 30 years ahead?
Well, I think we need to really change people's behaviors and I think people genuinely don't realize that we are in a climate emergency. And I think our scientists fall into the trap of thinking, we just got to show them the numbers, the data. Let's show them that graph of the, and it just doesn't resonate for people. And in a way, I think what we have to do is something quite unscientific. What people respond to is a story. This is why I think science at literary festivals is so important, because we have stories to tell, and we need to tell our science as if it's a story, which will then engage the emotions of our audience. So sometimes although we have data across the world, perhaps the best thing is to tell a story of a particular community that has been hit extremely hard by the climate emergency. And that's what might actually convince people, along with the data, that they need to engage and do something. I think vaccination has been a big issue, and people being anti-vax. And the reason they've often become anti-vax is because of one scare story that they've been told. So I think I like George Monbiot's kind of idea. You can only overturn one story with another story. So we've got to show them the data, yes, about vaccinations, but also show them just one case of a kid that got measles and died because they hadn't had the vaccine. That story will probably be more effective than all of the data. So, but I think, science will have a lot to offer. We're already working on solutions about how to capture carbon in the environment, the more innovation that comes up with. Safe nuclear power, for example, we already know that would be a fantastic way of getting off the dependency on coal, but already that still has a bad story about it. We need to address that. Also, just changing our eating habits. if people understand the impact that eating beef has on our environment and the change that could have. So I think science will be coming up with solutions, but we already have some solutions there that we need to persuade people to change their behaviors in order to try and avert this crisis.
And the last question, what's the new research that you're working on right now, which you're very excited about, which may come to fruition?
Well, I've been working on a conjecture in my own area, which is the research of symmetry, for some 15 years. So, it's a really tough problem. It's about a kind of pattern that I've seen in this world. Whether it will be have any impact on the world outside of my own area of research, who knows? But that's also why it's so important to continue to fund Blue Sky's research, because although it might look totally useless what I'm doing, in maybe 2 decades time, what I've discovered will be the key to some new innovation that's dependent on this kind of world of symmetry. So, I do my research because I love to discover truths about the universe, universal truths. I love it just for the sake of the discovery of these new ideas. But actually, mathematics, we get our money because so many innovations have come from people just playing with mathematics just for the pure joy of it. And it's not about utility. That's not what drives me, utility. What drives me is just the passion for knowledge, and utility comes as a secondary byproduct.
Marcus du Sautoy, thank you so much for speaking with us in terms of a joy of learning and a joy of knowledge. I'll come to questions in a second. Thank you so much for being with us here. Absolute pleasure.